All right, we're on our 48th lesson. And I'm Marion Fox. We're studying the biblical flood. And we're looking at eras in modern geology. And we're looking particularly at this instance, not so much geology as maybe archaeology is here, but this is radiocarbon dating techniques we're looking at. We looked at them last week. We're looking at them again this week, and we'll finish the radiocarbon dating techniques and the problems with them. We see some problems with radiocarbon dating. Now, assuming you're able to see the file, if you can't, you need to speak up, okay? The initial quantity of radiocarbon is not known with any certainty. They have to assume it. So when you make an assumption, you can make any assumption you want. If you backdate, if you reverse engineer it, you can get any date for the specimen that you want. If you assume a certain quantity of the radiocarbon, how much was there at the time the specimen was buried or ceased to be alive. This section of the study will demonstrate through many instances that the initial quantity of radiocarbon is not known. We'll prove it. We'll give proofs that it's not known. And therefore, the whole system is flawed because remember we have four variables in the equation. N sub O is the initial quantity, and they have to assume a value for it in order to actually get a unique solution to the equation. By unique, I mean one of a kind. I'm going to give about 17 slides, which will demonstrate that the N sub O, the number or the quantity of the substance, the radiocarbon in this instance, at time zero, is not known with any degree of certainty. Now, these quotes, these sites are all in my book, and you have them and you can go through them if you will. Shaw offers 10 dates on reeds and Hoffa grass from Theban tomb 157 that have Neverwinter, which can be dated to the first 17 years of Ramses II, that is 1304 to 1287 BC. Now, let me point out, there is some reason to believe that some of their dating of the Egyptian chronologies are in fact wrong. But we'll not go off into that at this time. We'll deal with that later. These dates have a calibrated carbon-14, C14, carbon-14 range from 1610 to 820 BC. Now that would fit in with the dates 1304 to 1287. So it's a calibrated carbon C14 range. Now keep that in mind. And so they've calibrated. Remember, in the 1950s, they began to have atomic bomb tests, and there was a spike of carbon-14 that affected things at that time. And so they have to go back and recalibrate it. Also, they had two problems. The decay rate was not known with certainty, and the decay rate that was assumed was in fact found to be wrong. Not only that, but they assumed that it was at equilibrium, that is the amount of carbon-14 being produced, mostly by hydrogen neutrons, but also hydrogen protons by lightning and also by meteorites, objects coming in from space, that these sources, the amount produced was equal to the amount decaying, and so it was at equilibrium, and that assumption was known to be false. In Hedges wrote, the major reservoir of 14C, that is carbon-14, the deep ocean, contains significantly older CO2, that carbon dioxide, so that marine organisms shown an anomalous age about 300 to 500 years too large in most coastal waters. So what he's saying is that the marine organisms appeared to be older than they really were. because the amount of radiocarbon in them was less. The older 14C, carbon-14 component, can be followed up through the food chain. And human populations whose main source of protein is from the sea should also have an older date for their bone collagen. This is actually the case. So the people that eat seafood, the carbon-14 in their diet is older. That is, they don't have as much radioactive carbon in that diet. And that's probably better for them, for their health. This may be a reason that seafood is good for you to eat. Maybe one reason that they haven't even figured out yet. But it's less radioactive. Radiocarbon in it has decayed more. So there's not as much radiocarbon in the seafood. Now, so this seafood looks like it's older. If you date it by radiocarbon than it actually is, about 300 to 500 years too large. Now remember, less radiocarbon in their system means it's older. So if it has less radiocarbon in the seafood, it looks older. Now, but these are fish and seafood that are just pulled right out of the ocean and eaten and examined. Evidence is presented to show that modern mollusk shells from rivers can have anomalous radiocarbon ages. So mollusk shells in rivers, that's clams, freshwater clams and so forth, and oysters, have anomalous radiocarbon ages. That is anomalous, it doesn't go by what they expect. Consequent errors of shell radiocarbon dates may be as large as several thousand years for river shells. So you take river shells and they may have an error. They appear to be several thousand years older than they actually are. The most noteworthy feature of the results is that the analyzed modern mollusk shells from river environments give uncorrected radiocarbon ages in a range of 1,010 to 2,300 years. That is, these are modern analyzed mollusk shells. They just, the animal died a few days before they examined it. It looks like it's 2,300 years old or 2,000 years old or so. Again, this is a major error in their values, a tremendous amount of error. The observed carbon-14 deficiency of modern freshwater mollusk shells and of continental waters have been explained mainly in two different ways. As a dilution effect resulting from the incorporation of inactive carbon from limestones and other rocks. In other words, they say that it's been diluted by inactive carbon, that is carbon that doesn't have radiocarbon in it. It's already decayed from limestones and other rocks. Now, the limestones were deposited during the flood. Keep that in mind. And secondly, from fractionization effect attributed to biological exchange processes, including the rate of exchange of CO2 across the air-water interface. So here's a claim that some organisms actually reject carbon-14 and don't prefer to take it in. And so they're claiming that this affects it too as well. And then the rate of exchange of carbon-14 across the air-water interface. Now, evaporation of carbon dioxide, the carbon dioxide, in order to evaporate out of the water, to get out of the water, has to get enough kinetic energy to liberate it from the water, to move out and be expelled out into the air. And the problem with this is that carbon-14, that is carbon dioxide that has carbon-14 in it, weighs more and it takes more energy to make it to get it out of the water. Now the problem with that is that should actually make it look younger, because it ought to retain more carbon-14 than it would carbon-12 or even carbon-13. So it's going the wrong direction, actually. But Terrestrial snail shells, Hedges tells us, these are land shells. Terrestrial means on the land. For example, appear to contain carbon up to 1,000 years older than the vegetation they feed on. Okay, so somehow they don't have the amount of radiocarbon in them. When you look at the vegetation, they're eating what radiocarbon it has. This means the snail shells cannot be used to date anything with radiocarbon. So, and this is fractionization. They think that these snail shells, these snails, will actually reject the carbon-14 somehow. In the cases when the magnitude of 14C, that's carbon-14, deficiencies is unknown or underestimated, potential for misdating is extreme. Now, this is an admission. Now, this is a quote right out of scientific journals. For instance, if the 14C, carbon-14 depletion in Big Spring, now this is not the town of Big Spring, Texas. This is a spring called Big Spring, and he'll tell you where it's located, were attributed entirely to hard water effect. Now, hard water is water that has a lot of calcium in it and minerals. Shells from the spring would date at least 22,000 years too old. So these shells are way out of date. The shells from that would date to be 22,000 years old, and yet they're still alive. And they don't live that long. That's a major error in dating. Since there's no limit to the size of reservoir deficiencies, the potential for misdating, particularly of samples from arid areas, is also unlimited. So in arid areas where it gets pretty dry, you can misdate something greatly. You have a tremendous amount of misdating of the material. It would look much older than it actually is. Note the magnitude of these errors. They're massive. Rubin and Taylor discussed the errors in dating living clams and snails from freshwater environments. This is another source of it. These deficiencies correspond to errors of approximately 800, 2,000, and 3,000 years. Page 637. Again, this is Rubin and Taylor. And again, all of these sources are cited, and they're from materials that are readily available. Much of it can be found on the internet, at least in libraries, good university, college libraries. Errors of this magnitude just cannot be ignored. They're too massive. An error of 1 or 2 or 3%, we might ignore it, but these are several hundred% errors, and maybe 1,000% errors. Errors of this magnitude call into question the integrity of the whole process of radiocarbon dating. These are errors we found. We know these are errors. How many errors are occurring that we haven't even found yet or haven't even discovered, because they assumed that there was a certain amount of the material radiocarbon in them at time zero, and they assumed the value of sub-zero. And we're going to see this as we go further. During the 1952 excavations of the settlement site adjacent to the south bank of the Durrington Walls Henge Monument, a well-preserved mass of wood charcoal was found. 2 radiocarbon tests on a sample from this charcoal were made. The results were indicating a date of 2620 to 2630 BC from the charcoal. The date of that, the date is archaeologically unacceptable. We cannot accept the Durrington Walls radiocarbon date, which is roughly a millennium too high. In other words, it's dated 1,000 years too high. In other words, when they say it is 2600 to 2620, 2630, they say it's a millennium 1,000 years too old. It ought to be about 1620 to 1630 BC. Way off. Now, the other information they have dates it at a younger age. This again is a significant error, nearly a 100% error in the dating of the process of this charcoal. Now, let me point out, we're going to explain some of the problems we have with it as we go through this. Therefore, radiocarbon dating, and this is another one, this is Dort, another quote. These are extensive quotes. I don't have quotation marks around them, but the rule is if it takes more than 3 lines in a document, you don't put quotation marks, you indent it. So in my book, these quotes are indented, so they don't have quotation marks around them. I left quotation marks off. Therefore, radiocarbon dating of marine organisms yields apparent ages that are older than true ages, but by an unknown and possible variant amount. That's an admission. It's an unknown and possible variable amount. Therefore, the several radiocarbon ages determined for the mummified seal carcasses cannot be accepted as correct. Here are seals that they know when they died, and the dry air, the dry cold mummified them, and they have these mummified carcasses. They were there, and then a year or two later, they come back, and these mummified seal carcasses were there. They know within a year or two when the seals died, and so they were in a location, and so they can't accept the ages of them. For example, Dort continues, the apparent radiocarbon age of a Lake Bonny seal known to have been dead no more than a few weeks. It died, and so they found it. And it was determined to be 615 plus or minus 100 years old. A seal freshly killed at McMurdo had an apparent age of freshly killed now, 1,300 years. And we know seals don't live that long for sure. So this is a massive amount of age. A seal may be 1 or 2 years old, and it appears to be 1,300 years old. That's something like over 1,000% error. That's a massive error. And if you take a seal that has been freshly killed at 615 years, plus or minus 100 years, and that's still about a 600% error, approximately, in that ballpark or neighborhood. The assumption that the value of the radiocarbon at T equals 0, that would be N with the subscript 0, is known as disproven by these cases. We've proven it. That they've shown that it's just they can't know what it was. And it's not science to begin with because you've got to verify it empirically to be science. So they had to make an assumption. Nunez and Walker discussed the errors in dating grape remains. Now, we're just going to other organisms which were found in Spain. The matter in hand concerns discrepant radiocarbon dates for paleobotanical samples obtained during the excavation of a seal in Neolithic, that is, a Copper Age deposit in southeast Spain. Now consider the dates from the mummy of Ramses II. A sample from under the heel has a calibrated radiocarbon age of 1340 to 1370, plus or minus 70 years. A sample from the abdomen has a calibrated age of 1030 to 1100 years, plus or minus 70. Same person, the same mummy, okay? There's quite an error in it. Radiocarbon dates on cobs, that is, like corn cobs, we call it corn. The term that was used by the American Indians is maize. And so this would be what we call field corn, or eating corn. Radiocarbon dates on cobs, long believed to be among the earliest collagens in the New World, that would be North-South America, make it necessary to question the standard 5000 BC date for maize domestication. A similar adjustment several years ago accommodated direct age determination of human bones, thought to be some 11,000 to 70,000 years old, but found no older than 8,000 years. So there's close to a 10 to 1 ratio, right? And between 11,000 and 70,000 years, it could be a 4, 5, 6 to 1 ratio in the error in it. That's human bones. Chronologies for the adoption of maize. This is what the American Indians, what we call corn in the United States. and adoption of maize agriculture north of Mexico have been revised accordingly. For some reason, however, the old Mesoamerican sequence persists unchanged in new edition of textbooks. We have shown that it's wrong in the dating of it, but the textbooks still have the old dates, which have been rejected. They still put it in the books, he says, for some unknown reason. I tell you, the unknown reason is that they're locked into their thinking. They're not open to evidence. They're not looking at the evidence, not revising their books according to evidence. In recent volumes and articles devoted to aspects of investigation, they have not changed it. The old sequence, which we've rejected with evidence, is still being taught. The kids in school, the young people in school are still being taught error, and they know it's error. That's amazing to me. In cold climates, wood may remain preserved for centuries without decay. See, that's a problem we run into. If the wood is used for fuel, the usage of charcoal from the fire to date things would give incorrect dates for the time of the fire. That's another, see, that would throw it off. Possible antediluvian wood that had no radiocarbon or almost no radiocarbon was preserved in the glacial ice or in other places. It was used by post-diluvian man for fuel. So this stuff would look very, very old. And so if we date by that charcoal, we've got a misdating of it because they have rejected the idea that there was a flood, like Peter said people would do, foolish people would do in 2 Peter 3. And so that would be another problem that they'd run into. Our half-life equation, if you look at it, N sub t is N sub O, e to the minus lambda t. Now, they've assumed the value of N sub O up here. Keep that in mind. That's what they've done. They've assumed it. They made an assumption about that value. N sub t is the quantity remaining after time t, and I would admit that they were pretty accurate in their measuring of this. Although the problem they had initially was, for quite some time, in many of their earlier measurements, they had to take several grams of the carbon in order to analyze it. Now they've got a better techniques for analyzing it now in order to have this big quantity. They had to destroy the organism just about in order to get the carbon out of it to see how old it was. And so they would take just a sample of it. I think they were guessing early on. The initial quantity of the substance in sub O, and that we don't know. We've already shown how variable it can be, how far off they can be. Lambda is the decay constant of the substance, and they assume they know that. And the assumed value that was given by Libby whenever he introduced this system, radiocarbon dating, has been determined to be in error now, and it's not at equilibrium also. That's two assumptions, both of which are false. Now then, when you take that formula and algebraically solve this formula up here for t, the variable t time, you have to solve it and manipulate it, divide both sides by N sub O, take the natural log of both sides, and you'll have minus lambda t equals on the left-hand side, and then you divide both sides by minus lambda, you'll have t. That would be your equation for it. But your problem is you're assuming you know the value of N sub O, which they don't know. They've got to make an assumption for it. We're going to show that today K constant is not it wasn't even known originally. They had to change it, but they're even wrong on this. We're going to see this as well in just a moment. So again, they've made assumptions. Mathematics, when you've got 4 variables and you only know 2 of them, you have to assume the third one. You can assume any value you want, get any amount of time you want to get. You can reverse engineer it. We're going to show there's evidence that that's exactly what they do, that they reverse engineer it. They plug in a value of assumed the initial quantity N sub 0 and enough to give them the date that they think the the document, the object was, organism. This section of the study will determine that the decay constant of radiocarbon is not known with any degree of certainty, and that it is variable, not constant. The decay constant, that's lambda of the substance. The next slide will relate to the decay constant. Other slides will show that statistical methods are invalid with radiocarbon. We'll show that. We'll show two things. The beta minus emitters. Now, a beta ray is a high energy electron. Alpha particle is a nucleus of a helium atom. Alpha particle has 2 protons and 2 neutrons in it. And sometimes we get an alpha emitter from radioactive decay. Sometimes we radiate a gamma ray. And so we won't go through all of those processes. But the beta minus emitters, the beta is now sometimes we can get a positron coming out, a positive electron, which then decays pretty quickly. But that would be a beta plus emitter. But we won't go into all of those decay processes of nuclear physics. The beta minus emitters, that's what we have with 14C, carbon 14, cobalt, and cesium, cobalt 60 and cesium 137, have had their decay characteristics altered. They have altered the decay characteristics of these 3. This is what Dudley tells us. Anderson claims the decay rate of radiocarbon does not follow the Poisson distribution. Now, when you get into mathematics, it has to follow that distribution in order to use the statistical methods that they're using on it in order to evaluate it. And it doesn't follow it. So that we got a problem with that. So the statistical methods don't work, and you need new methods to analyze it. And we've already shown Dudley claims that the decay the rate has been altered by certain processes. Now, when we see here, assuming the absence of artificiality, at least under the 2-sided conditions of measurement, the desorbing monolayers, we're not going to get into the chemistry of desorb and adsorb, and the positively charged monolayer surface systems, the beta emissions, that would be your beta particle, and it'll be a beta minus here, detected by external counters, positions adjacent to the absorbed carbon-14 labeled monolayers are not properly described by the Poisson distribution. In other words, they're not following the decay rate that we would expect with the formula. And so we can't analyze it with this formula. Here's our techniques. A key aspect of the procedure in both laboratories is the addition of a selective dissolution step, which removes potential contamination. Diogenic processes can add insignificant amounts of carbon with high 14C and 12C. That's carbon 14 and carbon 12. Carbon 12 is not radioactive. Most carbon is carbon 12. 6 protons, 6 neutrons in the nucleus. Carbon 14 has 6 protons and 8 neutrons in the nucleus. It's radioactive. It decays. And he's talking about ratios in corals, the ratio of these in corals. But selective dissolution techniques can remove such natural contaminants. So now he says we get diogenic process, we get processes, and we get the wrong amount of carbon 14 in there. But how do we know it's the wrong amount? They assume the age of the coral, that's why. And if they get too much in there, they say, well, this coral is older. We know it's older because it's in certain rocks that are old. And then we know it's old, so we have to throw away that extra carbon 14 that's in there. That's what they're saying. We have to remove that contaminant because it looks too young. We know it's older because it's an old rock. And how do we date the rock? We dated it by the carbon-14 or the carbon process. Now, this would happen also we're looking at rocks, it would look at the uranium-thorium process too. We were also concerned about potential inaccuracies in 230 thorium TH ages. Corals with ages that are known independently from annual growth bands and 14C dating demonstrate that 230 thorium ages are accurate for carefully selected samples younger than 8,000 years old. So now they're saying we can look at it. So we're looking at the thorium as well. That's radioactive as well. They're looking at that. Now remember, they keep going back, harking back to the radioactive decay, radiometric dating techniques. But the problem is they got 4 variables, they only know 2 of them. They need to know 3 of them so they can solve for the other one. They have to assume the initial value, and it's not scientific because they didn't see it. They didn't see it 8,000 years ago. They weren't there to measure it. However, now Edwards tells us some corals older than several tens of thousands of years, see, they assumed it based upon the rocks it was in or where it was located, have initial U-234, that's uranium-234, to uranium-238 ratios, greater than modern marine values. Thus, exchange of uranium may have occurred after skeletal growth. So what they're saying is we don't have the right ratios for the age we think these corals are. And so we know it was contaminated because it was in rock that was that old. We dated it by that rock. We know it's wrong because the rock is that old. And how do we know the rock's that old? Because the assumptions we made confirmed it to be that age. Okay. Again, it's ludicrous. How does Edwards know how much contamination entered the sample? He first dated the rock, he dated the coral, and then he used the dating to assume the amount of initial nth of O value in his equation, the initial value of the 234, U234 to U238 in the sample. Now here's another one source, but alas, there are flaws even in the cleverly contrived radioactive calendar. Bone absorbs very little carbon-14, and yet in the ancient camping sites, bones are the major evidence left behind by the lost Americans. So bone doesn't absorb it, doesn't absorb carbon-14 very well. Yet we're dating it by the amount of carbon-14 in bones. Well, if bones don't absorb it, they're going to have a disproportionately small amount, making them look older. Teeth and tusks do absorb carbon-14, as does wood, even in the form of charcoal. So we have to look at teeth and tusks. So again, we can't use bones. They're going to make it look way too old. The teeth and tusks absorb it. So again, we're looking at different parts of the body absorbing it at different rates. In some of the earliest experiments, now here's what I was talking about a while ago. Laboratory technicians needed a pound of teeth or a pound of ivory to derive a carbon-14 date. For crying out loud, you get a small sample, you don't get a pound of ivory or you might get a pound of ivory from an elephant tusk or something like that, but you're not going to get a pound of teeth from so many samples. Even if we had found a skeleton of a Folsom man, it's doubtful if a pound of teeth could be gathered to be dated. Even in deeply buried charcoal pits, carbon-14 might be leached out by percolating water. Might look much older. So he's saying if it's percolated out, it's going to look older than it really is. So if the carbon-14 gets leached out, carried out by the water that flows down through it, if it's buried, when it rains, the water goes down to the lower levels of the earth, sinks down in the earth, it'll carry things with it. The tiniest root hair mixed with ancient charcoal could be a part of the living plant and modern carbon-14 in it. This root hair would produce a date much too modern charcoal heavily leached by draining waters produced a date much too ancient. You got all these problems that you have to deal with. And you can't know that a tiny root hair had passed through and then decayed, or that water had leached out, making it look older. Even with these drawbacks and pitfalls, however, archaeologists and laboratory technicians began to hammer out the exact history of the earliest Americans. Had all these problems, they began to hammer out exact history. They can't be exact. Look at the word exact. They can't be exact when you have to make assumptions. The dates badly out of line. I want you to listen to this. The dates badly out of line were disregarded. If they got a date that was and showed it to be too old or too young, they just threw it away. These early workers were amazingly accurate in their guesses as to the antiquity of the earliest American hunters. So they were not using the dates that they got. It's bad science to throw away data. It is bad science to throw away data. And I repeat that. They're not very scientific when they throw away data. Gibbon almost admits that the archaeologists found the dates they were looking for in their radiocarbon dating. They threw away dates that didn't fit what their preconceived conceptions of the age, preconceived age. They just threw them away. Hedges tells us acceptance of radiocarbon dates, although once highly controversial, is now quite general. But even so, material is often submitted for dating in the spirit of adding a scientific precision to the archaeologist's pre-existing beliefs. I was told, and I don't get verified this, that when they're going to date it, they ask them where it come from, so they'll know about what the date was. So, well, that happened, or that it happens at least in some instances. The math used in radiocarbon dating makes the dating claims look precise. People tend to believe mathematical equations. But the problem is you got 4 variables, you only know 2 of them. And in fact, you know one of them fairly accurately with pretty good precision, but you don't know the decay rate. The decay rate has been proven and it's variable, radiocarbon decay rate. Quite a different approach was adopted by Callaway and Weinstein in 1977. They produced a radiocarbon-based chronology for early Bronze Age Palestine, but noted the great difficulties in reconciling the high dates produced by calibrated radiocarbon dates normally adopted by historians and archaeologists. They found a problem with it. As many as 25 of their 55 early Bronze Age radiocarbon dates had to be selected out of the study. That means they had to reject about 45% of them. And so they rejected 45% of their data because it didn't fit their preconceived notions. That's very interesting. That's very disturbing. That's not science. It's not even good mathematics. I tell you what, when I was working on my doctorate degree, if I'd have done that, they'd have laughed me out, and I would not have gotten my degree if I'd have done that with my data that I used. You don't throw away the data. You have to use the data you get, because that's what you have to do to be good science. But they rejected 45% of their data. And he just says it's quite disappointing. I say it's shameful. Not just disappointing, it's shameful. Archaeologists are unscientific in their methods, selecting data that agrees with their bias and rejecting contradictory data. That's not science. That's not good thinking. And they're not science when they do that. And of course, it's not even science to begin with because it's not verified by the empirical method. A generation of archaeologists have lived with radiocarbon dates by picking and choosing some of which they accept and others which they reject. Does this habit to continue, Newgrass tells us? He's scolding them for it. this is what they do. So you can't believe what they're saying. A PhD candidate would not receive his PhD if he were to reject contradictory data and only accept confirmatory data. They wouldn't give him his PhD. But these guys are out there already have a PhD and they're doing it and they're getting by with it. Why? Because the whole system is set up to be atheistic and hold earth and reject the Bible. Now, let me summarize this, and the lesson will be yours. Certain organisms have significant errors in the radiocarbon dates of the specimens. And the known ages of the specimens, that should be known ages of the specimens. There's evidence that the decay constant of radiocarbon is not constant. We've shown that. There's evidence that there has been dishonest handling of the data. What? If a person were in the class, and I've taught some statistics and taught some classes where we had to use statistics in college, if a person did that with the data, I'd have given them an F. I would have flunked them. They wouldn't have gotten any credit for that problem that they were working with. They threw the data away. You get the data, you use the data you got with your measurements. Now, if you think you've got an error in your measurement, you explain that in your analysis of your data when you analyze it. This is dishonest handling of the data. I'm ashamed that these men would be called scientists, that people would swallow and believe what they say. Very disappointing to me. This concludes our lesson here. I hope that it's been useful to you. I'll just fix that right now, the known ages of the specimens. Now,